Hello and welcome to the Daily Space for today, July 26th, 2019. My name is Dr. Pamela Gay and I am here to put science in your brains. Today we have a variety of news stories coming to us from, well, the Earth and beyond. And that first one is one I actually almost didn't bring to you. And the reason for that was I was foiled by a rather bad title. This morning I received a press release that was titled, "Einstein's General Relativity Theory is questioned, but still stands for now." And I get so many press releases of people who are just like, "We are suspect of Einstein's relativity. We do not think it is true, and we tried to prove that it isn't, and it's true." And I just don't like this stuff. And I know it's clickbait. And in all fairness to UCLA, they were probably trying to get clicks. But I almost didn't open this story. And the only reason I opened up this story is there wasn't a whole lot of other news to cover today, and I was hoping that if I opened it, it wouldn't suck. And the truth is, to my surprise, this super ill-named, ill-titled press release actually delivered a really cool story describing how Andrea Ghez, a professor at UCLA, has a new paper in the magazine Science, which I don't actually have access to, so I'm showing you an old graphic. Apologies about that. And this new paper describes 24 years of observations of the stars that are orbiting the supermassive black hole in the center of our Milky Way galaxy. And in the 24 years that she's been observing these stars, Ghez has been able to capture the entirety of some of these orbits. And to do this work, Ghez had to actually pioneer a new way of doing observational astronomy that is now used probably by some of you out in the audience. What she does is she takes high-speed images that are very short in time of the center of the Milky Way galaxy, and then aligns these images on the bright spots and adds them all up to beat down the noise. And what she's doing is she's correcting for the constant movement of the Earth's atmosphere. And this technique, which is essentially the same thing as taking video and aligning the frames and stacking an image, which a lot of amateur software now allows, well, this technique was the first thing that allowed us to finally be able to see stars moving around our supermassive black hole. Now, the innermost of these stars, named S0-2, has a roughly 16-year orbit. I'm sorry, I need to take a squeaky toy away from my puppy. Stella, what the heck did you bring? Stop. I'm slowly developing a pile of toys taken away from the puppy. So the innermost of these stars, named S0-2, has a roughly 16-year orbit. And this data is now enough to allow the full orbit to be seen. And this time domain data lets astronomers go from the two-dimensional data of X and Y on our sky and transform that into the three-dimensional motion over time of the star. And the reason they have to do that is you have a planetary orbit, and the planetary orbit can be anywhere along this rotation. And because we don't know the rotation, it's hard to know if the orbit is super elliptical or if it's almost round and super tilted. Using mechanics, we can figure out, okay, so if the supermassive black hole has this mass, which we can actually figure out by decoupling all of this, you have multiple equations describing the motion of the star, and those multiple equations allow you to simultaneously solve for the orbit of the star and the mass of the supermassive black hole. And doing all the maths, they've confirmed once again the mass of the supermassive black hole, but they've also confirmed the three-dimensional orbit of that star. And the reason that this press release has such a terrible title is they had to use the relativistic corrections to Newton's equations of motion. And everything worked perfectly. Everything matches Einstein, which is exactly how it should be. But they wanted clicks. So I guess the moral of the story is science works and you can't judge a press release by its headline. Okay, we're just going to move on from that. Science works. Now, continuing to talk about science that takes into account a whole series of data over time, we have observations of the star T Ursa Minoris. This is a star located about 3,000 light years away in the constellation Ursa Minor. It's a variable star. You can figure that out from its name, actually, because variable stars are named after the order in which they were found in a constellation. So A Ursa Majoris is the first star that was found to be varying in the constellation Ursa Minor. B is the second, and so on and so forth. You get to Z, and it goes back, and it starts over with AA. You get to ZZ, it then starts with numbers. Anyways, looking at this particular star, which is about 2 solar masses, astronomers have been observing the periodicity of this star is changing over time. And this is a much older star than our sun. And so it's further along in its life cycle. It's a massive red giant that is actually starting to sputter as the nuclear reactions in its core begin to run out of fuel. It's essentially that point where your engine's like, dude, you should have got gas. And your engine starts sputtering because it has fuel, but not really. This star has fuel, but not really, and is starting to sputter. And you can actually see that in this diagram. This particular diagram uses Julian dates where each number represents one day. And this particular calendar starts in March 31st of 2001. And over this period of time, we can see that the star's brightness is varying somewhat periodically. The amount of time that it takes is pretty regular. And then towards the end of the graph, while it starts to get around to day 5,000 or so, everything just kind of goes to pot. And the star isn't pulsating the way it had been. And what we're seeing is the star over time is running out of energy, and it's collapsing down, it's heating up, and it's believed that within the next 30 to 50 years, the star will then begin expanding out and getting fainter once again. So we're actually seeing one of the last pulsating breaths this star is going to take. Now, what's particularly cool about this is we often talk in astronomy about how we can't see the universe changing on human life scales. Well, this is 2 different stories where, well, with Ghez' work, this goes back to 1995. I was an undergraduate when this research started. This is work that started in 2001. This is research that has been done pretty much within the lifetimes of most adults out there who are old enough to drink and regret paying taxes. So this is super cool. We're seeing stars orbit. We're seeing a star not too different from our sun evolve. And things change over time. And sometimes we're lucky enough that they're changing over our time. Now, one of the things that is also changing over our time is the literal landscape of California. This is a GIF that I brought to you, I believe, last week, or GIF, I don't care how you want to pronounce it. This is a GIF or a GIF showing how the Little Lake fault line, which was disrupted in the Ridgecrest earthquakes on July 4th, the land moved several inches, and we can see that in the satellite imagery. Now, this particular fault line, it didn't move very much. The earthquakes were out in the middle of nowhere. There were some water mains burst. There were a whole lot of fires started by gas lines that burst. But overall, there wasn't massive loss of life. There wasn't billions of dollars worth of damage. And because of how the Little Lake fault line aligns with the landscape of California, it's not thought that this particular earthquake can add to the stress on the San Andreas Fault and trigger that fault line to go off. Because that fault line, when it moves, it does more than just crack the landscape. If you want to see the full power of a fully operational fault line, the San Andreas Fault is the place to go. And the thing that is easy to forget is this particular fault has areas of the fault line that are moving feet per year relative to one another, while other parts of the fault line aren't moving at all. And if you have two surfaces that are trying to move relative to one another, and only some of those areas can move, it's going to build up pressure. It's going to build up energy. And at some point, that energy is going to release. And it's believed that the next time the San Andreas Fault has what is generally referred to as the big one, when that big one comes, this fault is going to slide as much as 30 feet in those places that currently aren't moving at all. That's going to be devastating. This fault line, it affects Los Angeles, San Diego, San Francisco. Millions and millions of people are going to have their days probably pretty much ruined when this earthquake gives. And many, if not most, earthquake experts think that the next big one will come in our lifetime. And given when they started saying the our lifetime, and given how old they are, they're likely referring to within the lifetime of the baby boomer generation. So folks of California, let this be a reminder that you need to have an emergency kit. And you need to be ready to take care of yourself for, well, at least a week and perhaps even longer. Now, the person to go to learn about how to make earthquake kits is Mika McKinnon. She's talked all about this on Twitter at various points, but the highlights are you need to keep a supply of your medication, you need to have water, you need to have food, you need to have a way to keep yourself warm, take shelter from the rain, and a change of clothes. And there's more, but that's the basics. And you can do things like when you get that 90-day set of prescriptions, set aside 30 days. And then when you get your next prescription, use those 30 days, set aside another 30 days so that you don't have to worry about your medication expiring. Build up habits that allow you to always be able to take care of yourself. And if you're a commuter and you don't have the benefit of working from home, you probably want to have an emergency kit both in your home and in your car. Okay, so I'm going to end there because, well, I kind of enjoyed experiencing this particular earthquake, the Little Lake Fault Line earthquake, from the safety of Hollywood Hills. I don't think any of us are looking forward to experiencing what happens when the San Andreas Fault lets loose. And this is a small fault compared to some of them, like the Cascadia Fault. And we're not even going to go there today. Okay, we're going to stop there. And I am now going to look in to taking your questions. So please go ahead, type them in at CosmoQuest X. And while you're typing those in, I'm going to remind you that this is a production of the Planetary Science Institute, working in collaboration with Youngstown State University. We are supported by you. We are here thanks to your donations, your bits, your subs, your patronage at patreon.com/CosmoQuestX. We are so grateful for everything you do. And we fully understand not everyone can give with a monetary donation, but there are so many other ways you can support this show. One of the best ways you can actually help us out is to go do science. We are trying to finish up mapping through the most likely to be suitable for landing sites on the asteroid Bennu. So please click on over to bennu.cosmoquest.org and help us map out a rubble pile of rock that is in a near-Earth orbit, and help us find that place where a spacecraft can land momentarily, grab a bit of soil, and then bounce away to bring that soil back to Earth. Okay, and if you can't always catch us live, and we are live most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific, that's 6 p.m. London time. Well, if you miss an episode live here on twitch.tv, that's okay. We also are over on YouTube. Just look for the hashtag Daily Space on YouTube, and all of our episodes are archived for you. And here I go, spelunking into the questions. Scanning all the way up to the beginning. I think I scrolled into a different stream. There we go. Guido, I'm so sorry that it is still so hot in Europe. I know you guys don't have air conditioning to deal with it. That is miserable. All I can do is shake my head at that one. Space! Ruru2 writes. Yes, space! I agree. Let's see. Scrolling. So the question is, what is the squeaky toy I took away? I don't know. It's by BarkBox. I absolutely adore it. Hold on. Having trouble figuring out how to hold it for the camera. So there's its face. It's by BarkBox. It's where most of my toys come from. I wonder if its label says what it is. BarkBox. Yes, I know you are BarkBox. No, it doesn't say what it is. It's cute, and it squeaks, which is the problem. They'll get it back. Yak! I bet it's a yak. I agree with you. It does really look like a yak. Jingle bells. Is it Christmas early? I don't see jingle bells on it. So Fenring said one of the reasons that he canceled, or she canceled, I don't know your gender, Fenring. One of the reasons they canceled their American Scientist sub in favor of New Scientist is that main articles in Scientific America were written by researchers, which was not always great compared to New Scientist articles that are written by science journalists. This is true. I like Science News over both of those. New Scientist sometimes gets a little too clickbaity. But Science News is my favorite place. And yes, I did have a really weird noise generated by my phone making noise. Sorry about that. Yeah, they measured that star for the last 14 years, Falco. Yes, Fenring, the disruption on the Little Lake Fault does look like a lot, but part of it is you're seeing changes in lighting that can be much more dramatic. Looking to see what other questions. I'm just randomly replying to comments right now. Looks like today is a pretty question-free. So, Jayshan asks, any talk of more satellites to explore the asteroid belt? Yes, there is a planned Chinese mission. That's all I know right now. It's planning to also do a site selection and sample return. I'm hoping that I get to be part of it as well. It's a new breed of animal for the dog toy. I do think it's a yak. Will European storm Spitsbergen? I don't understand, Larry. I'm just going to go with I don't understand. But I think this is a yak. Okay, so that's all I've got for today. It is Friday. I am going to spend my weekend continuing to work on getting things set up, to better art, record, and audio from the basement, where it's temperature controlled and I don't have to turn on heat or air conditioning because ground. Oh, Larry's asking, yesterday's close binary neutron stars, will it go kilonova? Yesterday's close binary was actually 2 white dwarf stars, and white dwarf stars don't have enough mass to go kilonova, so it will simply end up repoofing into a rejuvenated star, live a new life, and die as a not quite 1 solar mass star. So a kilonova, Falco, is when you have a massive, fast-spinning giant star. So here I'm talking tens of solar masses. In the last days of its life, when it goes supernova, the rotation leads to a strong magnetic field, and that magnetic field can direct the energy of the supernova explosion out the poles of the star, creating a gamma ray burst. These are some of the most amazing supernova that we have. Nova, on the other hand, are when you have a binary star system, normally a white dwarf and a companion of some sort, and the white dwarf steals material from its companion, and that material periodically undergoes its own nuclear reactions, either exploding on the surface of the white dwarf or the disk of material that has been stolen itself heats up enough to explode. So there's all sorts of ways for things to go boom in our universe. And I am now going to go get lunch. And from there, I'm going to continue getting ready to improve the quality of the show from day to day and week to week. So I believe that I have the ability today to roll credits. I think the software will let me. And let's see. I'm going to roll the credits. I'm going to click the wrong button and fail to roll the credits. I'm going to try and roll the credits. And I'm going to remind all of you, wherever you are in the world, have a fabulous morning, evening, or afternoon, and go outside and look up. Bye-bye.